Now, yesterday we had studied about the properties of ionic compounds. I did explain everything. Now, in this syllabus, extraction of metals is not there. Metallurgical part is deleted as far as the syllabus is concerned. But we go to do about metal activity series. So therefore, you note down metal activity series. Metal activity series. Write down arrangement of metals. Arrangement of metals. Arrangement of metals in ascending or descending order. Arrangement of metals in ascending or descending order. Arrangement of metals in ascending or descending order of their chemical reactivity. Arrangement of metals in ascending or descending order of their chemical reactivity is known as metal activity series. Arrangement of metals in ascending or descending order of chemical reactivity is called metal activity series. Now, this metal activity series, the metals are arranged in ascending, that is increasing order chemical reactivity or decreasing order chemical reactivity, whatever it is. But it is ascending or descending order of their chemical reactivity, ascending or descending order of their chemical reactivity with hydrogen. So we say it is a metal activity series, but that metal activity series is having hydrogen also in it. Hydrogen is placed in the metal activity series. We know hydrogen is a non-metal. So if you remember, I told you, hydrogen is the only non-metal which is physical properties according to which it is a non-metal, and chemical properties it is a metal. Why do we say? All metals are electropositive. All metals are electropositive. Why we say electropositive? Metals have the tendency to lose electron. Metals lose electrons. Why do they lose? Their valence electrons are less than 4. So to get the stable configuration, what do these metals do? They keep on losing the electron. And you know that you have studied in 9th standard, an atom has got equal number of electrons and protons. Number of electrons and number of protons are equal. So in that situation, if an atom has lost some electron, then it becomes positively charged. So that is why we say metals are electropositive and non-metals are electronegative. So hydrogen, in most of its reaction, hydrogen tend to lose electron. Hydrogen tend to lose electron means it is electropositive. So metal activity series involve those elements which are electropositive. Hydrogen is also electropositive. Therefore, hydrogen's position is there in the metal activity series. It was a question asked, why metal activity series is activities of arrangement of metals and how come hydrogen is placed? So you must write it. Metal activity series means elements which are electropositive. Hydrogen is also electropositive. Therefore, it is placed in the activity series. Understood it clearly? Now, in CRT book, the activity series is given. The same order you'll have to write down. Now, how do we say that this metal is more reactive than this? Say, for example, aluminum is more reactive than Fe, or Mg is more reactive than zinc. How do we say that? The metals are arranged in the ascending order. That means you write down in metal activity series. In metal activity series, those metals which are placed above hydrogen in metal activity series, those metals which are placed above hydrogen can displace hydrogen from diluted acids. Those metals which are above hydrogen in the metal activity series can displace hydrogen from diluted acid. Now remember, whenever we talk about diluted acid means HNO3 is not included. Remember that statement. Are you understanding it? HNO3 being a strong oxidizing agent. We have studied it. The compounds that are formed by the reaction of metals with HNO3 is different. So leaving out that HNO3, whether it is HCl, H2SO4, all these acids will react with the metals which are above hydrogen, will displace hydrogen. Understood it? So that is why. Then write down those metals which are placed below hydrogen in the activity series. Those metals which are placed below hydrogen in the activity series cannot displace hydrogen. There is a question asked, how does copper react with diluted H2SO4? The only simple one-line answer is copper is below hydrogen in the activity series and therefore copper cannot displace hydrogen. So it's a reaction displacement. Remember the first chapter we have said displacement. More reactive metal displaces less reactive one. More reactive non-metal displaces less reactive non-metal. That is what is a reaction displacement. So no displacement of hydrogen by the metals which are placed below. Understood it? But remember, metals which are placed below hydrogen get reacted with concentrated acid. Yeah, when copper is made to react with concentrated H2SO4, what do we get? Copper sulfate, H2O and SO2. Remember that. Don't ever say that those metals which are placed below will not react with acid. It is the statement is they will not react with diluted acid, diluted HCl or diluted H2SO4, but they get reacted with concentrated H2SO4 and concentrated HCl. Understood it? So metal activity series, one must. This is a reaction to that of how hydrogen is displaced. Now, how about other metals? How would you suppose if this is a question which is quite often they ask? You will be given Mg, zinc, Fe, copper. 4 metals are given, and the question is it's a lab part, laboratory experiment also. Arrange these metals in the ascending order of their chemical reactivity. Arrange these metals in the ascending order of their chemical reactivity by making them react with their respective salt solutions. That is Mg, MgSO4, copper, copper sulfate, zinc, zinc sulfate, and Fe, FeSO4. All 4 solutions are to be taken. And into these solutions, all these 4 metals which are polished and kept. If the metal has got some oxide, remove it with the sandpaper, then introduce these metallic strips into these 4 solutions and see where the reaction has taken place. Mg and MgSO4, no reaction, you know that. Whereas Mg displaces all other metals. You can see it. Copper will be displaced, zinc will be displaced, and Fe will be displaced by Mg. So we can say Mg is the most reactive. Similarly, all other metals can be arranged. This is how metal activity series is made. Clearly. Top one, it is still a doubtful question. Different books are different. Potassium is mentioned, it as more reactive. Potassium is more reactive than that of sodium or that of lithium. All these metals, sodium, potassium, etc., when you leave it in the atmosphere, they catch fire. Sodium also catches fire, potassium also catches fire. When these metals are put into water, they react with water also faster. That reaction also will be taking place. So how do you compare it? We cannot, in laboratory method, we cannot compare these 2 metals. By simple reason is, you want to make this sodium to react with potassium chloride or potassium to react with sodium chloride solution. These metals being more reactive, they immediately react with the water. You know that sodium, when it is put into water, it floats on the surface. Dancing sodium, we had studied it. So what happens? So instead of getting it reacted with the solution, they will be reacting with the water. So we cannot. And if sodium metal is put into water, it catches fire also. So one cannot guarantee that this is so. So what we can do, this is by the chemical reactivity. How? Potassium's 1 valence electron. See the electronic configuration of potassium, 2 double 8 1. its one valence electron is away from the nucleus. Now studied in ninth standard law of gravitation. Force of attraction is inversely proportional to the square of the distance, right? So nucleus exerts force of attraction to the electrons. And if the electrons are far, attraction is less. Though potassium has got 19 protons in its nucleus. And when we talk about sodium, sodium's electrons, the valence electron is in the third shell, 281. So distance is less, force of attraction is more. Potassium's case, distance is more, force of attraction is less. Therefore, what is possible? Potassium can lose electron much more easily than sodium. And remember, metals are the one which have the tendency to lose electron. So potassium loses electron much faster in the sense that, so remember the statement I said, every atom loses electrons for which energy is absorbed. For which energy is absorbed. So potassium loses its electron by absorbing less energy from the surrounding. So immediately it is lost. Sodium will lose its electron, it takes little time because it needs to gain the energy. Therefore, we say potassium is more reactive than sodium. Whereas magnesium, copper, zinc, and all these things we can accommodate because magnesium is not going to catch fire in air. You put magnesium in copper sulfate, the reaction will take place. You can see it. You put magnesium in FeSO4, you can see the reaction take place. You put Mg in zinc sulfate solution, we can see the reaction take place. But condition is, it must be the salt solution, aqueous solution. So I told you during the reaction displacement, I told you why should we need aqueous solution? When the compound is in the form of solution, then only it has ions, right? CuSO4 is soluble in water because it is ionized into Cu2 plus and SO4 minus. So ions are needed for the transfer of electron. Ions are needed for the transfer of electrons. Are you understanding it, what I'm telling? So this is the reaction of displacement. Means in metal activity series, it could be ascending or descending order, whatever it is. You need to say that if you are writing from potassium till gold is or platinum is written, you need to say that it is the decreasing order. Understood it? And platinum to potassium you write down, then you can write down it is the increasing order of metal activity. So either you need to show by arrow, whatever it is up to you in any method you can write. But remember, this is how the activity series is made. We make them react with the salt solution. If copper has displaced silver and silver cannot displace copper, then copper is more reactive. Understood it? This is about the reaction displacement. Now next, write down non-metals. Non-metals. We need to study about that also a little bit in case if it is asked, one should know that. Compare with metals. Metals have its valence electron less than 4. You know what are valence electron? Electrons in the outermost orbit. Therefore, non-metals have the valence electron more than 4. So any element which has got more than 4 valence electron, then it is a non-metal. So therefore, to attain the octet configuration, what do these non-metals do? They take the electron, they accept the electron. And to a neutral atom, when electrons are accepted, then what happens? That atom or that element becomes electronegative. Therefore, we say non-metals are electronegative. Compare it. Metals are electropositive because they have a tendency to lose. And once the electron is lost, it becomes positively charged. Non-metals are negatively charged because they gain electron to get the octet structure. So therefore, non-metals are electronegative. Understood it well? Now, next. Most of the non-metals are gases, and write down bromine is the only liquid non-metal. Bromine is the only liquid non-metal. Bromine is the only liquid non-metal. Rest of the non-metals are solids or gases. Rest of the non-metals are solids or gases. Bromine is the only liquid non-metal. Rest are either solids or gases. Few examples of solids you can take: sulfur, carbon, phosphorus, iodine. These are few examples of solid. Then gaseous one: nitrogen, oxygen, chlorine, etc., etc. These all are gaseous non-metals. Remember, bromine is only liquid non-metal. Now, chemical properties. Write down. Non-metals combine with oxygen to form non-metallic oxides. Non-metals combines with oxygen to form non-metallic oxide, which are acidic in nature. Therefore, non-metallic oxides are known as acidic oxides. Non-metals combine with oxygen to form non-metallic oxide. In fact, they are solid non-metals. So they burn in oxygen to form their oxide. And these non-metallic oxides are acidic oxides. You can understand. When carbon dioxide is dissolved in water, we get soda water, that is carbonic acid. Sulfur trioxide dissolved in water, we get H2SO4, sulfuric acid. Sulfur dioxide dissolved in water, we get sulfurous acid, H2SO3. N2O5 dissolves in water, we get HNO3, nitric acid. E2O5 dissolves in water, we get H3PO4, phosphoric acid. So non-metallic oxides are acidic oxides because when they are dissolved in water, we get acids. Next, non-metals do not react with diluted acids. Non-metals do not react with diluted acids. Now, listen, this question, why don't they react with diluted acids? Why non-metals do not react with diluted acid? Remember, with diluted acid, the reaction is reaction of displacement. Understood it? So hydrogen is an electropositive element and non-metals are electronegative element. So electronegative one cannot displace electropositive. Remember the displacement. A metal can displace another metal. A non-metal can displace another non-metal. So therefore, electropositive hydrogen cannot be displaced by electronegative non-metal. And that is the reason non-metals do not react with diluted acids. Understood it? Whereas, these solid non-metals react with concentrated sulfuric acid or nitric acid, H2SO4 or HNO3. Solid non-metals react with concentrated H2SO4 or HNO3. Then the non-metal gets oxidized to its acid. The non-metal gets oxidized to its acid. And the concentrated acid gets reduced to its non-metallic oxide. Now see, we have taken sulfur. When sulfur is heated with concentrated H2SO, but this is not given in the NCERT book, but those who are interested in chemistry should know about it. When sulfur is heated with concentrated H2SO4, what have I told you? Sorry, concentrated HNO3. The sulfur gets oxidized to its acid. So what are the products? H2SO4 plus, what is the concentrated acid we are taken? HNO3. The acid gets reduced to its non-metallic oxide. Which non-metallic oxide? Nitrogen dioxide plus water. That's it. HNO3 and H2SO4 are strong oxidizing agents. Therefore, they undergo the reduction. So they reduce the non-metal to its, when the non-metals are oxidized, they become its acids. Now, simplest example. What happens if carbon is heated with concentrated H2SO4? Carbon should be oxidized to carbonic acid. What is the formula of carbonic acid? H2CO3. And we know that H2CO3 is an unstable acid. Am I right? Carbonic acid. So H2CO3 will be decomposed to H2O plus carbon dioxide. So that is H2CO3. Then the acid gets reduced. H2SO4 is getting reduced to SO2 plus H2O. Understood well? Simple. If phosphorus is heated with concentrated H2SO4, phosphorus gets oxidized to its acid. What is acid? H3PO4 plus concentrated sulfuric acid gets reduced to SO2 plus H2O. Similarly, if phosphorus is heated with concentrated HNO3, what happens? Phosphorus gets oxidized to H3PO4 and HNO3 gets reduced to NO2 plus H2. Understood it? So remember, non-metals do not undergo any type of reaction or displacement with the diluted acid. Whereas with concentrated acid, they react. It is not the reaction of displacement. Understood it? Next, write down. Some non-metallic oxides are neutral. We have studied it. Non-metallic oxides are acidic in nature, but some non-metallic oxides are neutral. Simplest example, hydrogen burns in oxygen to get H2O, water, which is neutral. Understood? Hydrogen burns in oxygen. Hydrogen is a non-metal. Understood? That is reacted with oxygen. We get H2O, that is neutral. Remember, hydrogen properties are entirely different. Forget about that. Then, carbon plus oxygen gives carbon monoxide. Carbon dioxide is acidic. Carbon monoxide is neutral. What is the reason for why carbon monoxide is neutral? Because carbon dioxide is acidic because it gets dissolved in water and we get acid. Whereas